So we are here today to do the assignment of chapter number 5, periodic classification of elements. So we'll do the question based on this chapter number 5 also, as well as I'll explain you the concept first, then we'll do the questions. And questions are framed such that these are totally NCERT based question, and all questions are very important and expected to come in the final exam. Okay, so periodic classification of elements, this is the chapter number 5, in which we'll have studied that how elements, different elements are being arranged. So basically there are three different scientists, mainly four, who have given their own theory for arrangement of the elements. So first one is Darwin's triad, second one is Newland's law of octave, third one is Mendeleev periodic table, and after that last fourth one is modern periodic table. This is the final arrangement of the elements. Okay, so for every scientist, what you have to do, the theory which he have given, then his achievements, and third one is his limitations. These things we will do. Okay, so before starting with the first scientist, few things which are very important for this periodic classification of element chapter number 5 are that first question comes that why there is a need for arrangement of the elements. Can anyone want to tell why there is a need for arrangement of the elements? So this is our question number 2. I am asking the answer to question number 2. Hopefully all are listening me.
Yes, sir.
Sir, for understanding the properties and compounds
Properties of the
orderly.
elements, yes, so that we can study the properties of the elements, and not only study but we can compare the properties also. So if we arrange all the elements in proper manner, then it would be very easy to study, to determine, as well as to compare the properties of one element with the another. What kind of properties, that sudden means we will do in this chapter only. What kind of properties, that will discuss in the modern periodic table, that there in for 10th we will do 8 to 9 properties, like what will be the valency, what will be the atomic size, how the size varies in period. These kind of properties we will study. So that's why there is a necessity or to classify the elements. So answer to the question number 2 is clear. Why is it necessary to classify the elements? So that physical and chemical properties of the elements can be determined, find, as well as compared with the other elements. Any problem to this? So here I
No,
can
sir.
write. Okay, so that property include both chemical as well as physical. Properties of elements can be determined as well as compared. That's why there is a necessity to classify the elements. Okay, so now we are talking about arrangement of the elements. Can anyone tell how many total elements are known to us till date?
180.
Very good. So total 100 elements are known to us till date. And how many of these are natural occurring?
94.
94 are natural occurring. Okay, very good. So this is basic things why we have to classify the elements. Now first scientist, Daubiner triads. So first before doing the questions, let me explain you what is the Daubiner triad, then we'll come to these kind of questions. Okay, so first scientist we are taking, we can take next page. Here I'll explain you. So we are discussing first scientist, that is Okay, so what is his theory? What he told about the arrangement, how the elements should be arranged? He said that he made a triad. Means, what is the meaning of triad? It is a group of three elements. Okay, so group of three elements is known as triad. So in his theory he said that when elements present in a triad, means group of those three elements, when arranged in increasing order of atomic mass, then average mass of first and third is equal to the nearly equal to the mass of the middle. Clear everyone? When elements present in a triad are arranged in increasing order of atomic masses, then average mass of, yes, first element and third element is nearly equal to mass of middle element. Clear? Now what is his achievement? His achievement is, according to his theory, he was able to find the three triads. So three triads he is able to find according to the arrangement he told. So what are the three triads? Now these same triads you will find in the modern periodic table. Now all know how to draw the modern periodic table, so maximum things you will get from there only. Okay, so let's move to the modern periodic table first, because whatever the examples they are taking, Daubner triad, Newland law of octave, or Mendeleev periodic table, everything is he have explained is present in the modern periodic table. Now all know how to draw the modern periodic table, or should I tell? If anyone say, then only I'll draw. Yes,
Doing, sir.
everyone know?
No need, sir. Yes, sir.
Okay, no need. So if you remember, now tell me, in first group how many elements, means what kind of elements are present in first group?
Alkali metal.
Alkali metal. So leaving hydrogen, can you tell next three element? Let's move to the
Lithium, sodium, potassium.
Lithium, sodium, potassium.
lithium, sodium and potassium. So that is his first triad. Okay, so now let's move to the question number 3. What are Daubner's triad? So can you now tell me what is Daubner triads? Daubner triads are group of three elements, and we have to explain also. So it is a group of three elements when arranged in increasing order of atomic mass, such that average of mass of first and third will be nearly equal to the middle one, that is known as Daubner triad. Clear now? Okay, so let's move to the question number 4. Give 3 examples of Daubner triads. Now we have to find the 3 triads. So triad number 1 is, as you told in modern periodic table, leaving hydrogen. So lithium, sodium and potassium, that is first triad. Then now triad number 2. Now tell me elements of group number 2, leaving first 2. Beryllium is first and magnesium is second. After that calcium, strontium and barium. This is the second triad. Can you learn it? And third triad is, now can you tell the elements present in group number 17?
Halogens.
Chlorine,
Very
bromine,
good.
iodine.
Again leaving first, leave the fluorine, then chlorine, bromine and iodine, these halogens. So now you can easily learn all 3 triads. Clear? Okay. Now question number 5. Lithium, sodium, potassium. As I told you, this is the triad number 1. Lithium, sodium, potassium form a Daubner's triad. The atomic mass of lithium and potassium is given as 7 and 39. And now you are asked to predict the atomic mass of sodium. So which formula will you use? Which is the concept of the Daubner? How? That Now lithium, sodium, which is the middle one? Sodium is the middle one. So you can say that average means mass of the sodium, mass of sodium will be equal to average mass of lithium and potassium. First element and third element का जो average है that will be equal to the sodium. This was the theory. Better respond at the same time. So mass of, you can say, lithium plus mass of potassium over 2. So lithium mass is 7 plus 39 over 2, and this you will get as
Sir, 23 will be answered. 46 over 2.
46 over 23.
23.
So mass of sodium is 23. This also you are already knowing that mass of sodium is 23, but we have calculated according to his theory. So question number 5 is also very easy. Sixth, what are limitation of Daubigner's classification now? So theory also we have done, concept, his examples also we have done, achievement are the same examples. He have found 3 triads. Now what are the limitations? Limitation is also in the same manner. So he is able to find only 3 triads, mean to say he is able to arrange how many elements? 9 elements, whereas failed for other elements. When he started his work, near about 34 elements were discovered, total 34 near about. So he have arranged only 9 elements, whereas failed to arrange other elements. Now any problem in Daubigner's triads, I have tried to cover each and every question based on this Daubigner triad. Can we move to Newland's law of octave?
Yes, sir.
Okay. So Newland's law of octave. Again, what you have to do, it's a theory, what the concept he have given, then advantages and limitations. Okay. So let me tell you what is the Newland's law of octave. Octave again like a Daubigner. Now octave means it is a group of 8 elements. So now what is his theory? How he have arranged the elements? He arranged, this is the question number 7 only. State Newland's law of octave and explain the system of classification of element as given by the Newland. So in both ways this question can be asked. So he arranged, now when Newland started his work, total 56 elements were discovered. So when all elements are arranged in increasing order of atomic mass, he found that every eighth element has a property similar to the first element. This is his theory, and he have made his periodic table named Newland's table. Clear now what was his theory? This video I will upload on the YouTube. Okay, so when you want to get the answers for this assignment, you can take from there. Okay, so maximum participation should be there. So 7th done. What is his theory? Now 8th, did Daubigner's triad also exist in the column of Newland's law of octave? Compare and find
Yes,
out.
sir.
Yes, so it is present. Why? Like you can think out that whatever the Daubigner work have done, it would be present in Newland, and whatever Newland have done, maximum things would be present in Mendeleev periodic table, and Mendeleev periodic table would be present in the modern periodic table. If we do not pay attention on its limitations. So yes, Daubigner's triads are also part of Newland's octave table, and compare and find out. One, you can find out that we do not have this Newland's law of octave, but still one example we can take. Same example you can take out over there. Like if we take about the example of lithium, this was one triad, sodium and potassium. Okay, let's take this example. Now tell me, using modern periodic table, after lithium, sodium is which element? Can you tell? Lithium is which element in modern periodic table? If you have learnt, it is third element.
Yes, sir.
Because its atomic number is 3, and you know how to draw the modern periodic table. वो तो आप एग्जाम में जाते टाइम ही रफ शीट पे बना के बैठोगे. So here we are saying that lithium is on which place? Third. And if I ask you sodium is on which place? Is it on 11th? Because atomic number is 11. बेटा बोलो जल्दी.
Yes, sir.
Okay, what is the position of potassium over there in modern periodic table? Is it 19th? Atomic number is 19. If we have drawn the modern periodic table over here, then I can show you. But you said me not to draw. Okay. So now after this third element, which element is this sodium? Eighth element. You can find that after third, add 8. Is it eighth element? Speak out. Third
Yes,
के बाद
sir.
third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. Is it eighth element? And after sodium,
Yes,
potassium is
sir.
also eighth element. Clear? And these all lie
Yes,
in
sir.
one
Yes,
triad,
sir.
means their property is same. Okay, and in modern periodic table you can find that this lithium, sodium and potassium lie in group number 1. So it means Newland, according to Newland also, this is good concept, correct concept, that every 8th element has property similar. So sodium have a similar property to the lithium and potassium also have the same property to the sodium, and Dobiner also have form one triad. So is this correct that Dobiner's triad also exists in Newland's law of octave? In both theories it was correct. Dobiner also form one triad arrangement done, and Newland also have done this arrangement, and modern periodic table also have 8th element property similar. So 8th is done. Now question number 9, what are limitation to the Newland's law of octave? Very good question, you can mark this as a good question. Okay, so there are 3 limitations. Now you can listen. First limitation is that he said that on total 56 elements are discovered. No new element would be discovered in the future, but later on there were many elements which discovered. After 56 today, you told that total 118 elements are there. Second limitation is like this 8th element concept of the law of octave, that the properties of 8th element similar to the first, this was valid up till calcium only for lower elements, and after calcium every 8th element property did not match with the first one. This was also a limitation. Third limitation is after calcium, as the property I said did not match, so few elements having a property similar he have placed in different groups, and elements whose properties are different that were placed in same group. So two examples, like 10th question, we have to find two pair of elements which were adjusted by Newlands in same slot. So that is, first pair is CO cobalt and nickel Ni, and second you can learn Ce and La. So these are the two pairs which he have adjusted means his theory was not correct for higher elements, was not valid according to his concept. So these are the two which he placed adjusted in the same slot. Now any problem in Newland's law of octave, his theory, his limitation and achievements we have not
No,
discussed.
sir.
You can say that he have made a his own Newland's table in which he arrange the elements in increasing order of atomic mass such that 8th element has property. So total 7 groups he have made. 8th property have a similar to the first. So 1 and 8th element will come in the same group. So total 7 groups he have made. Can we move to the Mendeleev periodic table? Any problem till now?
No, sir.
Everyone clear?
Yes, sir.
Okay. So now Mendeleev periodic table. What is his theory? So let's move to the question, because in questions also we have covered each and every concept, whether it is a limitation, theory or in between questions. And now you can see that total 11 to 22 questions are based on Mendeleev periodic table, and I expect none of the other question can be asked from this Mendeleev periodic table. Okay, so what is his criteria used by Mendeleev in creating his periodic table? So his criteria is, you can also write 1 point, increasing order of atomic mass, that is his criteria, increasing order of their atomic masses of the elements. And second is how he found this increasing order of atomic masses. There is another theory that total 63 elements were discovered when Mendeleev have started his work. So what criteria he have selected, that he have reacted every element with hydrogen and oxygen. Now why he selected only hydrogen and oxygen? Because these are easily available in the nature, and second, these are reactive elements nearby makes compound with the every element. So every element he have reacted with hydrogen and oxygen. So whatever the hydride or oxides, after reacting any element with hydrogen, its hydride is formed, and reacting with oxygen, its oxide is formed. He have written these chemical properties on the 63 cards, and when similar chemical properties, he pinned the cards on the wall and found that all were arranged in increasing order of their atomic masses. Now if anyone asks you how Mendeleev periodic elements are arranged in Mendeleev periodic table, we'll say that elements are arranged in increasing order of their atomic masses. This was the criteria he have selected. Now he have made his periodic law also on the basis of atomic masses of the elements. So state Mendeleev's periodic law. So what is the law? His law: properties of element, every element is periodic function of their atomic masses. Okay, so properties, this is again very important definition. Properties of elements are periodic function of their atomic masses. What is the meaning of this statement? Periodic function means after certain period, okay, there are groups and there are periods. So after certain period, the properties of the elements will start repeating. That is known as periodic function. And as the elements are arranged in an increasing order of atomic mass, so after certain atomic masses, their properties will start repeating. So that is periodic function of their atomic masses. Okay, so 13th now. Why among chemical properties Mendeleev concentrated on compounds found by the elements of oxygen and hydrogen? This answer I have already given, because these elements are reactive, nearby to make the compound with every element, and second, these are easily available in the nature. 14th now. What are achievements of Mendeleev periodic table? So achievements, mainly you can list 2 or 3 points for achievement. One achievement is like elements were arranged in an increasing order of atomic masses when he pinned the cards on the wall with the similar chemical properties. Okay, now second is very important. He have also left some gaps in his periodic table. Now what are these gaps for? For those elements which are not discovered yet but would be discovered in the future and occupy these gaps. So this is very important point, that Mendeleev have guessed that some elements will be discovered in the future, and he have left some gaps for those elements. Now which elements? We have to do the examples of those elements which are discovered later after the Mendeleev, and he have also given the name to those elements. Now again I am going back to the modern periodic table. From there you can learn. Okay, so if I ask you group number 13, group number 14, group number 15, and so on. Okay, what are the elements of group number 13? Boron, aluminium, and gallium, and there are many more, but for 10th we are doing up till 4th period only. Now group number 14, carbon, silicon, and germanium, and group number 15 is nitrogen, phosphorus, and arsenic. So which elements were discovered later? You can do it from the here only. So germanium, you can start from here, no need to write the elements for group number 15 also. Group number 13 and 14 are sufficient. Germanium, gallium, and one is scandium. In the group number 3 you will see that there is a element with the name scandium. So these 3 elements are discovered later. Will you learn these elements from the modern periodic table? Scandium, gallium, and germanium are the elements which were discovered later. Okay, so beside gallium, which other elements? So scandium and germanium are other elements. Okay, 15th. Now he have named these elements also which were discovered later. Suppose now gallium is discovered later, so he have left some empty space for the gallium. So what will be his name? Its name. So gallium was given a name, this gap was given a name by prefixing eka to the elements prior to this gap. So prior to this gap is aluminium, so what will be the name of this gap? Eka aluminium. Okay, so now what is the name given to the germanium? What was previous name when germanium, before germanium was discovered? It was, can anyone tell now? Eka silicon. And what is the name of for the scandium? It is eka boron. Okay, likewise you can learn eka boron. Okay, so all are attentive, listening, respond.
Yes, sir.
Others?
Yes, sir.
Yes, sir.
Okay. Question number C. Why Mendeleev left some empty spaces, gaps, same for those elements which will be discovered later. Give reason for the late discovery of noble gases. Now noble gases were discovered very late. What is the reason? Because these are inert in nature, very least reactive. That's why these are discovered later. 18th, what are the limitation of Mendeleev periodic table? Now Mendeleev periodic table also have a limitations. Okay, so what are the limitation to the Mendeleev periodic table? Number one, he was failed to fix the position of hydrogen. Reason is because hydrogen has a property like a alkali metals. Like alkali metal make the compound LiCl, NaCl, KCl, same way HCl. And as hydrogen is non-metal, so it will exist like other non-metallic gases, diatomic gases like O2, N2, same way H2. So position of hydrogen was not fixed, whether it should be placed in with the alkali metals or with the non-metals. Now you can tell that you know that hydrogen is given a fixed position in the first group and first period. It is placed among the metals in group number 1. Okay, second limitation was, like as I told you, that increasing order of atomic masses elements are arranged, but few elements were there whose atomic mass was greater but kept prior to the elements which is having lower atomic mass. That was also his limitation. Example is same, cobalt and nickel. Third limitation of isotopes. Now isotopes were not discovered at the time of Mendeleev. These were discovered very late. But as now isotopes are what? Having same atomic number but different mass number. So as isotopes have different mass number, so all isotopes should get different position in his periodic table according. But he have given a only one position to the isotopes. Like if I ask you how many isotopes of hydrogen are there? 3. Protium, deuterium and tritium. So these all 3 are isotopes of hydrogen only, but he have given only one place to the hydrogen, whereas according to the increasing order of atomic mass, these should get 3 different positions. So this is the again limitation to the Mendeleev periodic table. 19th, would you place isotopes these in same slot according to the different atomic mass, different slot according to different atomic mass, or same slot? Now this question justify your answer also. So this question is not based on Mendeleev periodic table if asked, because it is not mentioned in this question. So we'll answer according to the latest theory, that is modern periodic table only. So in modern periodic table every isotope get a same position. That is how modern periodic table have removed anomalies of the Mendeleev periodic table. So all isotopes have same atomic number 111 like hydrogen, so it should get one position. So these both isotopes are of chlorine, so chlorine will be placed in one slot only, same slot only. Okay, because of the same valency. That now you know that in group number 17 chlorine is placed, so one position only. Okay, 20th, give other names for eka boron. This I already told. Eka boron is scandium, eka aluminium is gallium, and eka silicon is germanium. These are the Gallium, scandium. These are the names. Now 21st, why do you think noble gases are placed in separate group? Because noble gases, their valence shell is already complete. These are having a valency 0. So these are placed in different separate group. These do not interfere with the other elements. Now you can say that in modern periodic table where noble gases are placed in group number 18. Okay, noble gases are placed in group number 18. Okay, 22. Use Mendeleev periodic table to predict the formula of oxide. Now you might be thinking that we don't know the modern Mendeleev periodic table, but you can make the formula using the modern periodic table only. So what will be the potassium oxide? So it would be K2O, because potassium is in group number 1, its valency is 1, and oxygen is group number 16, valency is 2. So formula will be K2O. Calcium oxide is CaO, second group, valency +2, charge, oxygen O2 minus. Aluminium oxide, aluminium +3, O2 minus. So formula is Al2O3. Silicon, it is in group number 14, family of carbon. So like CO2 makes SiO2. Barium is in the family of calcium in group number 2. So same way BaO. So now clear till modern periodic table. So modern periodic table will do tomorrow. So any problem till here? Now maximum question in the final exam in CBSE exam will be asked from modern periodic table only. So be ready to attend the next class. Okay, tomorrow we'll finish.